Hi, today we've got a repair video. Now this is a LG, model number is 42LH3000, 42-inch TV. This is 2009, September 2009 was the manufacture date. This was kindly donated to me by a friend. It failed on him and subsequently he purchased a new TV. And yes, so I've got it now and something to hopefully repair and hopefully should make a interesting video. Now what I'll do is I'll just go and turn the TV on and we can see what the current symptoms are. One of them being the fact the remote control doesn't seem to communicate properly all the time. Right, okay, so that's up and running now. So basically at the minute we've got some issues with colours. Now it's basically gone at the minute to the kind of inverted image. Now the original fault was having one line down the right hand side of the screen, which we will have a look at in a moment, followed by the whole screen going white. Very sort of washed out. You could make out the images but it wasn't great. At the moment, like I say, it's gone to a kind of inverted mess at the minute. It's doing all sorts of random stuff. Now basically there's a chip on the T-Con board, so I thought the T-Con board was probably going to be at fault. I did a bit of googling and yes, there seems to be a gamma control chip that's actually on the T-Con board, and that seems to be the point of failure. So I tried to reflow the joints on that, applying a reasonable amount of heat, but suspecting that more than likely, as per other forum posts, that the chip in itself was completely fried, hence the issues we're getting at the minute with the TV. And yeah, since heating it up I've managed to get it to do what it's doing now, basically, kind of complete mess. So that's what really does pinpoint that that chip is the cause of the problem. So if we just have a look around, we can see hopefully this line which we got running down here. This is not to do with the T-Con board. That line is actually created, these got various flat flex cables that bond across to the LCD, and it's just a connection of one of those. Now they are put on with a very expensive tool, something I certainly don't have or do not have access to repair that. So the line, we can get it to sort of go occasionally by pushing on certain points, so I would try and jam something in to sort of apply the pressure to stop that being all the time, but we're not too concerned about that. The main thing is to try and get the image actually correct as opposed to what we're currently seeing now. Okay, so please excuse the camera work. It's very hard to get this set up on a tripod. So this is the back of the TV. I've already had the cover off. I've also got most of the parts around the bezel removed as well. Just for ease of simplicity, there's quite a lot of screws to actually take out to get to this point. So here we've got the main power supply coming in. The caps all look okay. There's nothing obvious, no obvious signs of bulging or leaking that I can see. So I think they're probably fine. I'm not too concerned about that, but I may sort of just check the voltages coming off it at some point. And if we move across here, this is our main processing board. And then this flat flex cable running up here goes underneath and up to the T-Con board, which is behind that plate there. So we'll just whip the cover off that. So this cover over the T-Con board is held in with 5 machine screws. Now this is acting as a heat sink as well. It's not just solely a cover, so you do need this in place. And I think the reason for failure of this chip is simply the heat sinking. It's not been designed very well at all from that point of view. So you've literally just got the metal plate with some sort of areas that have been indented in there, and that's just pushing against the various chips on the T-Con board itself. So that might be something we can improve upon, probably some kind of thermal pad, something like that, but certainly even just a bit of thermal paste would probably make a big difference. So if we move those screws, that should now pop off like so. So we've got a single flat flex cable coming in. Now this had 2 little plastic clips on. Upon squeezing them to release the locking mechanism, they just literally snapped off. just so brittle because of the heat. So the way I'm going to remove it is from the point on the other board, and come off there, and then we've got two connectors here. You just pull back on the little black tabs there, and then the cables will be released. Quite fragile, so be delicate with it. Okay, so we're back at the bench now, and this is our timing control board, our T-Con board, that's been removed. This one is a ONV branded, I believe. This has got known issues. You got ONV or AUO, depends which way round you're reading that. I think it's AUO, comes up on the forum posts. Now the chip in question is the little one right down in the corner here. So that chip itself is an AS15-HF. I'm not sure, when I was looking on the internet to try and find replacement chips, I just got one off eBay that is brand new. It's still in the real packaging that it would come on. Now there do seem to be sort of different varieties. You've got the AS15-H, HF and a few other varieties, so I don't know if there's a massive difference in each chip, whether or not you need to use the actual specific HF1 or not, but I'm going to use the HF1 as I managed to get one of those on eBay. I paid about £1.55 plus about 65p postage. Okay, so again, here's the chip in question. So it's quite a high pin count chip, QFN package I believe. So I think the best way of getting this off is going to be hot air rework station. Soldering iron wise, if I bring my soldering iron in, you'll kind of get an idea of the pin pitch on that. So very, very small pins. You probably could do a bit of drag soldering, but there's not much clearance. You'd have to sort of go out that way. So a hot air gun, remove it. I've seen some other videos where people have taken these off, but they've just removed them and then plonked the new chip straight on. What I'm hoping to do is clean up the pads a bit first, use some solder paste, and then we will reflow it with the new chip in place. Okay, so I've got the hot air gun here. So I've got it set at the minute to 350. It should be hopefully hot enough, sort of medium airflow. Don't want to blow anything off the board. I'm not too worried about overheating this this chip, getting it off. That's not a major concern of mine because it is dead. However, of course, I don't want to damage any of the capacitors and resistors, etc., that are on the various points around the chip there. So I'm just going to apply a fair bit of heat and just hopefully get this to solder some melt on it. I'll try and get tweezers in on one corner, apply a bit of pressure. There is a chance we will need more heat than this. Okay, I think we're going to need to up the temperature a bit and see how we go. Okay, so I've certainly got applying a fair bit of temperature to that, and we're not actually managing to lift it yet. I'm not quite sure why. It may well be glued down as well. That is a possibility. But the board is getting very, very hot now. Obviously, I don't want to lift any traces when removing it, if possible. I think the only option we've probably got now is to go for even more heat, maximum heat of. Oh, there we are. I think we've got it. I think we got it. Yes, perfect. So certainly quite a bit of heat required to get that off. And sorry, I think that actually came off not on camera. So the board is still very, very warm. So hopefully that's focused in. So what I'm going to try and do is just use the soldering iron and a bit of desoldering braid and just try and clean those up a little bit, ready for the solder paste to be applied. Okay, so I've got the soldering iron heated up, so I'm just going to apply a little bit of flux across the various pads there. That's more falling out rather than coming out as it should do. Just check that. Right, anyway, let's not get distracted by the flux pen not doing what it's supposed to be doing. So, bit of a desoldering braid here, and just apply some heat over onto the pads. Okay, so that's that side done. Just rotate the board around a bit. Seems to be working quite well. The adding flux actually helps massively when doing this sort of thing. Okay, that's that side done. And then we've just got this corner here. Now I looked up the data sheet for this chip just to check the temperatures. So the maximum temperature for the sort of core temperature was 150, I think. It says lead temperature 250, 270, something along those lines. So hopefully that's, if we don't apply too much heat, just enough to get the solder paste to melt. I'm using the same solder paste as I've used in previous videos, which I'm not overly impressed with. What I've done this time, I've had it out of the fridge for about an hour and a half, 2 hours, and I've also placed it on the heater. It does seem to sort of clump up quite a lot, as it would do in the fridge, but I would certainly expect you know, an hour or two outside would be enough to sort of clear, sort of liquefy it a bit more. So we've got our pads now cleaned up reasonably nicely. So we've got on here, you probably won't be able to see it on the video, unfortunately. Let's see if we can get a better camera angle on that. Okay, that's slightly better. So what we're looking at is a tiny little triangle mark, which we can see over here. Now that's going to be the sort of pin 1 identifier, so pin 1 will probably be that pin there. So if we actually look at the old chip as an example, oops, yeah, I think this has actually been glued down in the past, or even possibly a bit of solder on the underside of it. I'm not quite sure if that's needed, but whatever's left there will get reflowed anyway. So looking at the chip in detail itself, if I can get it to focus on it, come on. Hopefully you can see there's a very small circle just over in the corner there, and so that circle needs to line up in position with the triangle we've got on the board over there. Okay, so here's our new replacement chip, so we'll just get that out of the package in there. Ideally you should be wearing a anti-static wristband for this sort of thing, but I'm not going to bother. Okay, so this is our new chip here, and yes, we got the pin identifier marker, little dot just in the corner there, so we know that that's going to sit in that position on the board. Excellent. So the next thing is to get some of this solder paste on, which is going to be a complete disaster, I'm sure. It normally is. I've got to definitely perfect the right method for doing this. It's probably in excess of too much, but we'll try. So it's still not quite as runny as I'd like, and no doubt I'm going to end up way too much on here. This is what concerns me with getting any ending up with any bridges on it. But we can probably just go over with a soldering iron afterwards and just touch up any areas which might be shorted out. Right, I think that's probably more than enough solder paste on there. try and get some of that off. Right. So if we place our chip, so making sure that our dot lines up with that corner. Now the next thing is going to be trying to line these pins up. This is kind of guesswork because I can't actually see where the pads are. Hopefully if I'm roughly in alignment, that should pull itself in to the correct pads. I'll see if I can get access to one of the edging ones there. Right, so that looks about right, so I think we'll get the hot air gun going. So I think with this one we'll go for 300. We know it's going to probably overshoot slightly actually. Go for 280. We'll see how we get on with that, see if that's hot enough or not. Yeah, I think we may need to up the temperature a bit, so I think I'm just going to hit it with a reasonable amount of heat, but not for too long. Hopefully that will do the job. Okay, perfect. So just let that cool down and settle. I think the issue now is just going to be sorting out any solder bridges that we've got. So we have got one obvious solder bridge down in the corner there, so that will need to be dealt with. And I think there may just be a few here and there, so I think a bit of drag soldering with the soldering iron hopefully will be enough to remove that. So I'm just going to apply a little bit of fresh solder on there. And again I think we'll go for some flux. And here. Okay, this is certainly not, it's not removing it as much as I would like it to. This method normally does work. This does certainly seem to be actually just creating a lot more bridges on this, so I think we're going to have to try something else. I think we'll go for a bit of a desoldering braid, see if we can just use that to try and whip some out. Yeah, having a look at that, it's very hard to tell, but it does look to me like a lot of these joints are definitely bridged together, and probably a lot worse now. So we haven't really done this very successfully at all. It was of course always going to be a bit of a hit and miss thing. Something this size, it's very difficult to get it quite right. I think what we do is we just sort of try and get as much of this excess off. Less is certainly more when it comes to solder paste, and of course in a factory this would be reflowed. Stencil would have put it on. So I'm just kind of hoping now if I sort of heat it up again with the hot air gun, what we'll do is we'll apply a bit more flux and try and just hope that when it melts again it just sort of pulls it to each individual pin, as opposed to ending up with a giant blob on it. Now I did only order one chip, foolishly, kind of hoping that that one would be okay, but worst case scenario we can always order another chip and replace this one. Okay, I'll just let that cool down for a moment. So looking at it, I can definitely see areas which I think are definitely more than likely going to have shorts across, and that certainly is one along there, that side. This side looks relatively clean. That side again does look quite well shorted, so I'm just going to get the multimeter on it and see. There's certainly no point powering it up if we've got dead shorts across it anywhere. Certainly not seeing any obvious indication there. What I'm doing simply is just probing on one of the pins, or sort of between a couple, and just running the other probe across, and then if these are obviously shorted out we should get some kind of beep in between them. Right, I've got one there, but that certainly isn't a short, as that's obviously internally. That's internal to the chip itself. Apologies, I think my arm was in the way there. Right, so I'm just going to have a closer look at this and just see if there's any obvious signs of any issues with it, and then we'll put it back in and power it up and see what actually happens with it. Okay, so I've had a reasonable look over it, and if it looks okay. It's very hard to tell with the naked eye, but looking at that sort of zoomed in quite well with the camera, it certainly looks as if all the pins are solder, but they don't look quite aligned. Yeah, that's reasonably well aligned, that side. That edge there, not too bad. That side looks slightly out, I don't know why. But yeah, it is just getting the right angle. Yeah, so I don't know, but that certainly nothing seems to be beeping out as being shorted. It does just look to me like that shifted very slightly, sort of half and half, but then it should show up on the multimeter if that's the case. So I think we'll risk that and see what happens if we plug it back in. That cap there has tombstoned itself a little bit there, got a bit wonky. Not to worry. Okay, so I've got that board is reconnected at the back. I haven't actually screwed anything in yet. I want to wait until this thing either works or doesn't work before sort of doing that. I can't get the remote control to work again now. I had this thing apart and cleaned it all out, and yeah, it's just, you see, you should see that on the camera image if it flashes. It sometimes works, you press and hold it for long enough. Yeah, so I might have to invest in another remote for it, but we have actually got some buttons on the side of the unit, so we're hit what I believe is power, and see if anything happens. Okay, so the light's pulsing, so that's a good sign. Oh, okay. That's not gone. It's not gone all white yet. Ah, yes. Here we are. Look at that. Yeah, that looks much better. Let's see if we can get a menu system up. I don't know. Yep. Okay, so we can certainly scroll through our normal menu system. AV1, AV2, so turn it back off again. So what I'm going to do, grab my laptop, grab a HDMI lead, and we'll just see if that is going through. Okay, so I've got the laptop hooked up, and just go to my website, and there we are. Absolutely perfect. We have still got the line on the side of the screen, and that's nearly the camera over there. So the line certainly is looking. We've got three distinct lines there, and different colour bands as such. We've got sort of purple, red, and green there. That, like I say, is nothing. Well, I mean, it's major, but it's not something I'm too fussed about at the minute. It seems to be affected by the flat flex cable, so I've got this set in a way that I can remove 4 screws and pull the whole front bezel off, and then I'll sort of jam some sticky pads or something in to try and hold that in a location where it doesn't do that. But overall, the thing looks okay. The whites are white, the blacks are black. I think we can probably call that fixed. So I hope you found that video useful. If you did, please give it a thumbs up. If you are not subscribed, please consider subscribing. There is of course no charge. And if you would like to help support me in making new content, then please consider making a donation via Patreon. Links below in the description box and via my website.